I'd like to bring up our sponsor from Avnet. And we have, hopefully, is Hari Kalyanaraman coming on? Oh, but here he is. Hari, welcome. I'm so glad.
Yeah, my apologies. I had a bit of a technical issue there for a second.
Oh, we are all learning. Well, please tell us more about Avnet and how you guys are working with machine learning at the edge.
Yeah, absolutely. Thank you, Stacey, and hello everyone. As I was listening into the segment, a lot of good, vibrant discussion about the different use cases and verticals as it pertains to machine learning at the edge. And Avnet today is excited to be a sponsor of this virtual event. At Avnet, we focused on helping businesses accelerate and scale their IoT solutions in generating value-driven insights. We address everything from hardware, software, applications, and more relevant to this conversation, AI, ML models, and any services that are needed to simplify the overall complexities of IoT. And one of the ways we do this is with our platform called IoT Connect. IoT Connect is a secure, scalable, enterprise-grade, cloud-based platform that addresses common industry challenges with pre-built, pre-packaged smart applications. There's a lot of good conversation before about, the build versus buy and, the pre-packaged solutions. That's something that, we offer through our platform. And with a standardized way to harness IoT, your company can quickly build solutions that turn your data into actionable insights. I invite this audience to learn more about our platform and our IoT partner program at avnet.com/IoT. Thank you again for your time, and I hope you enjoy the rest of your event.
Excellent. Thank you so much, Hari, for sponsoring and for coming to tell us a little bit about you. Hello, welcome back from the networking break. I hope you enjoyed the coffee I thoughtfully provided under your chair. No, I wish we could do something like that. That's kind of the less fun part about the virtual event world. But hopefully y'all got a chance to talk to each other. Y'all are doing a great job in the chat. I'm loving the discussion. I get to read over it in breaks. Just a couple housekeeping reminders. Again, not the Wi-Fi code, but we have networking and the expo available during the breaks. When you go to those places, you're going to kill the main stage, which means you'll stop being able to hear what's happening on the stage, and you'll end up coming back to us by clicking on the stage button on the left-hand side. So when you do that, you may have to hit play, or you may have to refresh if you can't hear anything. This is still a really new platform, so they're learning, we're learning, but I think it's a lot of fun. Reminder, in the networking area, you can go over there and you can randomly meet people and chat with them for about 3 minutes. It will engage your audio and video, so be presentable. Y'all are doing a great job in the chat, talking to each other, sharing information, and being kind, so keep up with that. We're going to be gathering our questions in the chat, so Kevin will be gathering those. You can just boop at Kevin or just drop them in the chat. He'll keep an eye out. And I think that's about it. So let's welcome Dan Jeavons, who is Dan Jeavons, who is the General Manager of Data Science at Shell. And we're going to be talking about how Shell's using machine learning and computing at the edge and all sorts of fun things. So hello, Dan, how are you?
I'm very well. Thank you very much for having me.
Oh, we're so excited. And thanks for doing it late at night. I feel like you should have a cocktail.
Absolutely.
You're like, I didn't know that this is that kind of conference, Stacey. Oh, well. My. All right. Well, let's just start off. Why don't you just tell us what you guys are doing at Shell with machine learning at the edge, and we'll take it from there.
Yeah, for sure. So let me first of all start off with machine learning and AI, because I think that's an important place to start. So within Shell, we've got a pretty holistic program focused on scaling up AI right across our organization. We call that Shell.ai, and it's really a change program that's designed to embed AI in every part of our business and organization. Because I think what's important to recognize about this whole journey, be that machine learning in the cloud or at the edge, and we'll talk about that later on for sure, is that actually it's all about business change. This is about changing the way that we do things in terms of the processes that we run every day. So Shell.ai is a pretty big deal. We've got about 3,000 people engaged in the change program right now. We've got about 1,200 people or so engaged in developing AI solutions in some way, shape, or form. And of course, we do a lot of work in the cloud, and increasingly we're starting to do some work at the edge, which is really exciting, and we see a lot of opportunities there. So I guess maybe start there and see where you want to go with that. But it's a big thing for us.
Yeah, no, that's a lot of people, and it's a good point about business transformation. I feel like a lot of the time in the tech world, we're all like, "This is cool, let's do it," and it is cool. And we should do it, but we also need a good rationalization. So let's talk about the use cases first at the edge. So what are some of the things you're trying to do? Because Shell is huge, has many use cases.
Yeah, so I think it's probably worth talking a little bit about sort of what we see the edge being good for. I mean, you alluded to it earlier on. I thought you did quite a good job in terms of talking about some of those cognitive senses, the simulation of human perception. And I think that's one of the key areas that we see real application for this. We tend to focus on the edge really for two reasons. Firstly, as has already been said, where it's a real-time use case. In other words, we need sub-second response. And so the edge is obviously the best place for that. The second scenario is where you've got really large data sets, which you don't want to ship over the network into the cloud. And so those are sort of the two areas where we're exploring this as an approach. And I guess there's probably a third where bandwidth is a real problem. So we already talked about situations, and one of your previous guests did my job for me, talking about some of the challenges that we have in embedding sensors in real-time operations in extreme operating environments within the oil and gas industry. And that's, of course, something we have to think about a fair amount. So those are really sort of the why are we using the edge. And so what we see is that there's a number of use cases that are emerging where that's highly relevant. You talked about machine vision. Inspection is key. We're already deploying a significant number of drones and robots, as well as subsea robots that are designed to inspect our facilities, our pipelines, remotely, controlled by humans at the moment for good reasons, for safety reasons, but effectively bringing back video feeds which can then be interrogated. Now, a lot of that can be done in the cloud, but in some of the filtering of those cases, particularly in remote locations, we see edge-based use cases for that, and we're experimenting with deploying models onto robots and onto drones on low-factor compute in order to do some of that processing. So that's one example.
I just want to clarify. So in this case, they're going over and they would be looking for problems, right? So they have a model that they're running against. Okay.
Yeah, exactly. So typically it's computer vision type scenarios. So to give you an idea, and again, one of your colleagues helpfully alluded to the case already, looking at things like corrosion on pipes, that's a good case. It takes people a long time to inspect some of these vast facilities and large amounts of piping. And so if you can have a drone or a robot that's doing that, 24/7, that's a huge opportunity in terms of just improving the whole inspection process, both in terms of effectiveness and efficiency. I will say one of the challenges is data, and no doubt we'll come back to that. But that's a great use case. As I said, it's kind of the same thing. We've got a similar example, subsea, where we're doing this on top of pipelines. And then we've got the same example where we're trying to do it in the air from drones.
Okay. And I think you're even using it at your gas stations, correct?
Yeah, that's an interesting one. So, I mean, again, what I will say is a lot of the things I'm going to talk about are early. They're things that we've worked with. We've developed them as initial small-scale pilots. We call them minimum viable products. And so I don't want to give the impression that we're there and we've got it all sort of nailed down, but at the same time we're making some very exciting progress. We've talked openly before about some of the stuff we've done in retail, looking at particularly safety applications. There's actually a lot of challenges from a safety perspective in terms of situations where you may have people who come and drive off or situations in which you have smoking activities at gas stations, and we've experimented with those cases. I will say that one we found particularly difficult to scale, and maybe that's something that we'll come back to, because I think that's something that in general we struggle with in Shell.
Yes, and that is such a beautiful segue, Dan. I love it.
Thank you.
So you have talked about how there's a lot of promise here, but your controversial opinion is that it's not there yet. And can you talk about why this is more hype than reality today? And by this I mean machine learning at the edge.
Yeah, absolutely. I mean, I think I do want to sort of start by saying machine learning in the cloud is very much now. We are doing a huge amount of machine learning in the cloud, and I just want to give you some ideas of the size and scale of that. It's important to say the oil and gas industry has been doing sensor technology for a long time and has been aggregating that into central environments for a long time. In fact, we kind of led the world in developing that technology, I would argue. And so, we've got over 1 trillion rows of aggregated data in the cloud, which we use to develop thousands of machine learning models which monitor our equipment every day. So in the cloud, this is very real, it's very big, it's very now, and we've talked very publicly about some of the things we've done in that space. I think partly because we've got very good connectivity anyway, and partly because this is quite difficult, we've struggled to get yet the scale that we want on the edge. And maybe just to unpack some of the issues behind that, I think the first thing is the operational challenge of running things at the edge. If you're running a device and you're running it on a rig or in a manufacturing facility, for us, the refinery, or for example, if you're running it on a wind farm offshore, or if you're running it on a solar farm, or if you're running it at an electric charging station, all of those things tend to be remote. And also are quite tricky to maintain for different reasons. So there's a whole logistical problem about the edge, which is what happens if the edge device breaks? How do you replace it? How do you manage it? How do you upgrade it? And some of that requires people still to go to the edge and figure it out. And that, I think, that failover and those sorts of things are maturing, but I would argue from what we've experienced are often not yet fully mature. And we've certainly learned a lot about some of the challenges of doing that. I think the second factor is simply cost, because there's often benefits to doing things in real time, but often you're willing to compromise, even in low bandwidth situations, if you are spending a large amount to have an edge device do the computation. So if you're really talking about high cost edge, it doesn't work at scale, because you end up coming back to the point, well, will I accept the latency on the use case in order to move the data back to the cloud? And often the answer is that that's more cost effective. So I think that's another scenario where that cost point for low cost edge with the right computational capabilities, I think that's emerging, and I would argue perhaps not yet fully there. I think the final thing is simply model management at the edge. I mean, for those that are in the machine learning space and have worked in AI for some time, you'll probably know that model management is a challenge anyway. So just being able to manage thousands of models is a real logistical headache, and it's something that we've been trying to figure out. If you add to that thousands of models running in thousands of edge devices where latency may be a problem, you actually have a lot of risk. And I heard one of your previous guests talking about firefighting scenarios, and I'd love to understand how they do it, because I mean that's an even more extreme environment. But for us, thinking about how do you manage those sorts of logistics and how do you maintain that at scale are some of the things that we're still working through. And this is why at the moment, a lot of what we're doing is still these minimum viable products and Pathfinder projects, rather than things that I would say are truly enterprise scale yet.
Okay, and that makes sense. So let's dig into those, because you said a lot of things.
Sorry.
No, that was good. That was a wonderful overview. So let's talk about I'll call it the people problem, which is dealing with like changing batteries. So talk to me about what you guys have experienced. I feel like you've got this trifecta of really remote operations. So you might have to like literally fly someone out over the North Sea. You've got highly educated, well, I don't know how highly educated, but you have deeply technical knowledge and probably doing some of this. And then you have, now I've forgotten the other one. we'll come back to it. But so talk to me about the challenge that you faced, or maybe use a project that you've tried to that you tried to implement where this became an issue.
Yeah, sure. I mean, maybe I'll give a couple of examples. I mean, I think the first and perhaps best example of this is, I did a bunch of work looking at how do you maintain and manage smart charging solutions for electric vehicles. Now, that might sound like a very simple thing to do, but what we found was in that scenario, some of the work had to be run in the cloud. A lot of it could be done there, but some things had to happen on the edge. So you actually had to be able to deploy physical hardware into the charger to control the interface with the car. And if you look at that example, what we struggled with that business model was the fact that effectively each installation of chargers and the combination then of the compute that goes with that, and then the comms box that manages that, and then the integration of that with the cloud, and then the management of that charger in the cloud as a discrete device, that was very, very complex. Now, it's not that it wasn't doable. We successfully deployed this end-to-end solution as it was to 4 or 5 sites. The issue that we had, though, was that when you start trying to do that and you start trying to do the economics of scaling that up in conjunction with the business model, when you look at the logistics of managing that, maintaining that, the people you have to have on the ground to do that in the location, the fact they have to drive around checking these things, you really start to realize that the math just doesn't add up in terms of the economics yet. And so we ended up moving to more of a cloud-based solution for a lot of these things. But it's just an example of where, a proof of concept that we've worked through, you can see how some of these challenges become really real. And when you're talking about some of these things, you're often talking at a few $100s per device. So there's not a lot of room for high cost compute in that.
No, and that's kind of gets to your second point about cost and the trade-off between, why am I doing this at the edge? Am I doing it because of latency? Is it worth $5 extra per compute cycle? And
exactly.
We'll talk about that. Actually, the next panel after this is going to be about business models for the outer edge, because they don't really exist yet. But let's get to the data modeling and keeping that, I don't know if it's coherent or keeping it synchronized or how to start thinking about that. But how are you guys dealing with that challenge?
You mean in terms of bringing all the data together?
Yes, and then figuring out how and where to send it, and making sure everything's working when you have. Oh, and we should also talk about the scale that you're talking about, because I don't think people realize it. Yeah. How many sensors, when we talk about Shell's edge, what are we talking about?
Yeah, I mean, I don't, to be honest, I think I don't even know. What I can say is that we've got literally hundreds of thousands of edge devices that are all communicating to our cloud. And by edge devices, I'm using that in the loosest possible term. It's everything from base sensors through to IoT devices, to cameras, to mobile devices and the like. I mean, as I said, we've currently got about 1.1 trillion data points aggregated in the cloud that we use for machine learning training. So it's a huge problem is bringing all that data together. And I think what I will say as well, and it goes to a point that one of your earlier guests was making, what we're trying to do is also learn about how do you build these secure, reliable, robust pipelines from the edge to the cloud, with then the underlying data structures in data lake stores, with delta management, because that's also an important point. And how do you manage all of that? And then how do you make sure you can take that and train machine learning models on top of it and manage those models and have end users manage those models? So that's basically the problem space that I spend most of my time thinking about, and how on earth do we set up a technology stack to achieve that?
Can you just give up on some of that and just say, we're going to dump 90% of the edge data because it's not interesting? Because that's what I feel happens. People are like, we're going to lose this and just do a model that says, I care only about these things and everything else just goes away. Or is that inclusive of all of that?
In fact, that's what we do, right? I mean, I think the big thing is, I mean, this is not all the data. we call it a curated data lake with good reason. We heavily curate the data feeds that we take in, because if you take in too much, it just becomes unmanageable, and also not useful, because data scientists can't get what they need in order to train their models. So we curate this quite heavily, and yet still, this is the sort of volumes that we're talking about, even pared down to things, because we are only bringing the data in that we want to use to train machine learning models. We're not bringing in all data. And we, to give you an idea as well, this is growing at about 10 billion rows a week at the moment. So we're expecting that that's going to grow pretty exponentially over time as well.
I can't imagine how you sleep at night. They're growing. The data lake is growing while I sleep. So talk to me about hardware. And this might speak to the cost issue too, but there's a lot of emphasis right now on machine learning at the edge in special processors. And I'm really curious, is that helpful? And maybe we should make the distinction between inference versus training, because we're not talking about training. And how, like, are those helpful, or do those just bring up costs? I mean, what is your thought process on that?
I think so. Let me answer that in two ways. I am quite excited, and we've obviously been experimenting with a lot of these deep learning chips at the edge for some time in the labs and so on, and we're excited about that. I mean, let's be honest. I mean, we were really excited with some of these early stage USB chip type deep learning frameworks that are coming out, which you can run on something really low form factor connected to a very low cost compute device. We see that having huge potential. I think what I will say is that we found that in practice, again, the cost becomes an issue, but also I think, to your point, I think the use cases almost need to mature a little bit. I mean, where I see this really being extremely valuable is in these settings where you have that real-time control problem, things like robots and drones, and where you're dealing with those in remote environments, as I mentioned, and that means that you have to have this really reliable interface for those machine learning models, and you have to be really confident that when you deploy that container to the edge, that it's going to work. And as I said, I think, and one of your other guests mentioned it, that I'm not. There are a lot of companies that are cracking this, and I know that, but I think a lot of it's being cracked in perhaps less challenging environments, where perhaps you have a bit more control, you've got a more reliable Wi-Fi network, you're not dealing with vast swathes of different facilities stretching over multiple miles, or similar with pipelines. I think that's our challenge of we have these logistical challenges of managing it, and these are the sorts of issues that we have to correct for every day. And I think sometimes, to your point, this is all about business value. And when you're looking at cutting edge technology in a job like mine, you often have to say, is there a simpler way to crack this problem? Because whilst I'm a technologist at heart and I love this stuff and I think it's amazing and I'm excited about the potential of deep learning at the edge, I know it's going to be really important in cases like computer vision. I also recognize that we've got to get things out and deployed at scale. And sometimes there are simpler ways to do that, sacrificing a little bit of latency, for example.
True. All right. And I'm going to be opening it up for questions. So if you have questions, send them and tag Kevin. In the meantime, for what you're doing, and we talked about this a little bit on our prep call, but not that you need more data, but I'm really interested in some of the data that you're bringing in. This has less to do with machine learning at the edge and more on terms of training things and getting access to things at the edge. But can you talk just a little bit about the idea of simulated data in training using that? Just because, again, I know it's more data, but I think it's a really interesting way to get info on the edge cases that we're trying to solve.
Well, and I think it's a really important point, right? So we talked about some of the data challenges, and even though we have a lot of data, the big problem that we have is that actually we often only have a very few examples of what we're looking for. So let me give some tangible examples for that. We deal a lot with things like corrosion. We deal with, for example, specific types of blockages in pipes. We deal with For example, situations in which you may only have a very small number of this particular observation in the subsea where a particular type of event has occurred, like, a net getting caught over a pipeline, for example. And so these sorts of things, we don't have many examples, and therefore it's quite hard to train a machine learning computer vision algorithm to actually detect them consistently, because you just don't have enough. We had actually the same problem in retail, believe it or not, because you don't have a lot of examples of where people have been smoking, because you don't always catch them, they're not always looking, it's not the right angle, and so on. And so almost always the things we're interested in are the quote unquote edge cases rather than the general norm. So it's quite easy to detect edge from standard pattern, but it's quite hard to detect the specific thing that you want. And so one of the things that we've been working pretty hard on is how do you combine simulated synthetic data with the real data that you have in order to generalize that such that you can actually train effectively. And we think that's very important as part of the future. So using that quote unquote mixed reality setting where you take a realistic image and then you look at the potential variation within that image, you simulate that, and then you start to create a set of synthetic data that is very effective in detecting certain classes. That's something we've seen boost our results very significantly in terms of use cases like computer vision. And we're convinced that actually this is going to be the future in terms of making things work well, both in the cloud and at the edge for some of these complex use cases.
I have to admit, Dan, that I am still stunned that people are smoking at gas stations. I feel like did they not see Zoolander? I mean, pivotal theme.
It is amazing, it is amazing. It was quite funny. We put it out there and I think people kind of sympathize with the problem because I think people related to it. So yeah.
Yeah, crazy. Okay, so some questions from the audience. Oh, this is a really easy one. Maybe I shouldn't say that. How small can the models get? What is the smallest model that you're running on the edge at Shell?
Good question. I guess in terms of how do you measure it, that's the question. I mean, I guess probably I couldn't give you the kilobytes, but it's pretty small. I mean, we're getting down to very small container type deployments for sure. Often, by the way, the reason they're quite small is because we're often doing initial filtering at the edge and then the verification in the cloud. So that's an interesting point as well, that often you are deploying small models to the edge, basically to reduce the data volumes, which is one of the cases that I alluded to earlier on. But you're talking, very, very, very small, kilobyte scale type model deploys. And I think the other thing is, we tend to try and think about what's the simplest model you can deploy to do the job. As I said, trying to reduce some of the complexity. Don't use a deep learning model when you can use something much more simple, for example.
Makes sense. Okay, let's see. Oh, it sounds like Shell is focused on getting data, centralizing the data, and then running the models against the data. Have there been any inroads in sending control signals back to the edge for process control changes?
That is a great question. So we would love to be there. And I think that is obviously the key towards automation. We have some really good examples where we're doing that. At the moment, though, and by the way, maybe I'll give one of the examples. So one of the things we're looking at is optimization for process control. So we are developing solutions where we have an advanced process control unit that's sending out signals. It's looking at all the parameters that are running, for example, in a liquefied natural gas train, and it's pushing those parameters back to a cloud-based environment, and then we're running optimization on top of that, and then sending advisory set points back down to the operators. Now, the key thing there is it's a really interesting one, because that's, and it goes back to the point I made earlier on around business process change. The question is, are you confident that the algorithm is able to perform in a way that you'll give it the trust to do it without the operator checking it? And I think, for us anyway, I would say probably technically we can. I think from an operational safety perspective, and also making sure that we understand these things as they're coming in, these types of fundamental changes, we are often having human in the loop. And I think it's an interesting point going forwards, because I do feel that the next generation of AI, as we move towards these highly complex systems, is actually going to require that human in the loop. because I think you do want the verification often, particularly in industries like ours where safety is such a critical issue. But indeed, I think more and more there will be degrees of automation where things do happen directly, and where we're pushing, for example, set points directly back to those controllers.
And when you're talking about, because we're not all in the oil and gas business, I know, when you're talking about that example, what exactly are the set points that you're talking about? What are they monitoring on the liquid mesh? I mean, just to give a broad example.
Sure. So I mean, to give you an example, I mean, what you're often doing is you've got a whole series of different sensors through the piece of equipment that's effectively generating liquefied natural gas. What's happening is in each of those sensors, you have a bunch of tends to be first principles based models that originally were developed in order to ensure that those things operate safely. And you have a series of set points, so upper and lower limits within which you want the entire process to operate. Now, the point is that obviously, as anyone knows, these processes vary quite a lot, and so set points vary too as to what the optimal set point is. And we have the ability to change those set points dynamically. We've had that for a long time, and we're now using sophisticated optimization techniques on top of that, and the large data sets that I talked about, in order to better inform those set points in near time or real time.
Okay. Oh, here's a good question. Who is driving the push towards machine learning at the edge at Shell? Is it your CTO, CIO? What data sources are they using to justify their business cases? Oh, and this guy wants your ROI metrics. Oh,
no, look, I mean, I think, as I mentioned, right, we recognize that this is going to be very important. You can see, I mean, if you think about our industry, in an industry that's predominantly remote, has a lot of real-time processes that require real-time intervention, that also requires to be able to scale across all sorts of different devices that we have. It's very obvious this is going to be an important theme for us. At the moment, what we're doing is we're looking at it very much from a technology lens. So directly to the question, it's being driven basically through our research, our technology division, because we see the importance of it. As I said, we've had a number of successes. I talked about some, maybe I'll talk about another one. So another example of where we're doing this at the moment is in the wells business. We have remote drilling rigs. And what we're trying to do is bring together machine vision technology with also real-time monitoring technology at the edge to provide much better insight around the optimum speed for the drilling process, for example. And we found that that's very effective. This is often a challenging process to do in the cloud because it's very hard to get this data from a remote drilling site into the cloud. And therefore, doing this at the edge makes sense. And we've seen some very effective field trials at that. But again, it's at the minimum viable product stage where we're proving that it works. But I mean, to give you an example, you can see the business case for doing this because you can remove a lot of the complexity in the processes. You can also do a lot of things in a more automated fashion. As I said, the inspection case is a great one for that. You can also have huge impacts on safety. So, and that's obviously a key driver for us. And often, for us, safety is so important that we do that almost despite the ROI. It's something that's just intrinsically vital to the way we run our business. It's something we care deeply about. And so I guess what I'm trying to say is that at the moment, one of the challenges is getting to that ROI to really scale it. We see initial benefits cases for doing it, but I think we're going to have to see more of that before it really becomes ubiquitous within our organization.
And how does this conversation within the organization work? Obviously, you have your billions and trillions of data points, and you have your 3,000 data scientists, right? So
yeah,
they've got a sense of what's going on there. Then you have the people who have actual problems. How do they meet and communicate? Like, who says, "Hey, I think this data could mean something to you that could solve a problem"? How does that conversation happen?
So it's a really great question, and it brings me to the heart of kind of the change program that is Shell.ai. So we actually don't have about 3,000 data scientists. We call them citizen data scientists, and that's important. We have a core team of about probably about 200, 250 people who I'd say are true data scientists. That's what they do. That's their job. And a lot of those are in my team, but there's other teams as well within the organization. And so what we try to do is we use those folks for some really high-end complex problems, typically coming out of research, things that are next generation problems in data science, machine vision. Some of the things machine learning at the edge, for example, would fit into those sorts of categories. But the way we identify the business problems is actually that we encourage the people in the business, because as you already alluded to, we have a lot of technical staff, engineers, people with a big background in process control, people with experience in subsurface, electricity specialists, increasingly, folks that have a deep background in power. And so, we've got a lot of these types of roles within our organization. And what those folks are very adept. Most of them have a mathematical or a statistics background. Most of them are very comfortable with learning about new types of models, data-driven models. And so we've developed a program where we train those people up. It starts with kind of entry level. We have a network. That's where the 3,000 people come together. We put calls out there. We show them what we're doing. That's kind of level one. We also then have hackathon events with people where we try and share with them some of the tools that are available within the organization to help them solve some of their problems. We then also have training courses. So we've partnered with Udacity to develop something for citizen data scientists where they learn about machine learning, Python coding, and the like. And so we take these people on a journey where they start to understand what it means in terms of embedding AI in every part of our organization. And what we found is that what that does, it generates energy within the organization. It helps people identify where the value is, because the people who have the problem are able to understand this is a problem to which I could apply some of these AI techniques. And we also then build that connectivity between the professional data scientists and those people in the field for those complex problems. And actually, many of the cases where we've had the biggest success have emerged from people in the business with those problems. And actually that tends to be where it's most effective, because they want the change. They're pulling us in to help them to develop the solution rather than it being a technology push.
Okay, and that should be really heartening to everybody who has these problems and wants to develop this, because these are programs you can set out. Obviously,
absolutely,
you may not have the deep engineering, technical mindset that many Shell employees probably have, but there are going to be those people, and building these programs is important. Well,
no, I was going to say absolutely, and we've done this in HR. We've done this in marketing in terms of working with different departments of people without technical backgrounds, and even there, these tools are becoming easy enough that actually people can get their heads around them and start to do some pretty amazing things. So I'm not saying they're ever going to develop a deep neural net which can be deployed to an NVIDIA chip, but they can develop a simple workflow which has a linear regression or the like in it.
Oh, even marketing people. Wow, those are people like me. All right, Dan, thanks so much for coming today. We appreciate it. And we'll let you exit the stage, and then we will bring up our next sponsor. Our next sponsor is Perceive, and I have the CEO of Perceive here, Steve Teig. They are actually a company doing one of those machine learning chips at the edge. And I am lying to y'all. I apologize. That will be at the end of, Steve will be coming up after this break. So we are going to go on a quick break. We will be back here at 11 o'clock. And again, excellent work, Shell. Please step over to the networking or the Expo Center to learn more about our sponsors. And thank y'all so much for sticking with us.